Hello and good morning friends, welcome to CEC-UGC live lecture. Dear friends, welcome once again to the another lecture on database management. As you know that we are carrying series of lectures on database management, and this is the third lecture on this very topic. And I would like to tell you all today we are going to discuss about various models which are basically used in designing the databases. So for this we have again with us in our studios Dr. Umar Shankar Pandey. He is Associate Professor in School of Open Learning, Department of Computer Sciences, Delhi University. As well as I would like to tell you all that he has authored numerous books, one on cloud computing, and another important publication, that is another important book of his, is e-commerce and mobile commerce technology. So taking advantages from his experience, I hope that this lecture is going to be one of the another lecture which is going to be very productive, very fruitful. So first of all, I would like to welcome our guest, Dr. Pandey. Dr. Pandey, welcome to the UGC lecture.
Thank you. About database management system. What is a database is and is not. The word database is commonly used to refer any of the following: your personal address book in the Word document, a collection of Word documents, a collection of Excel spreadsheet, a very large flat file on which you run some statistical analysis functions, data collected, maintained and used in airline reservation, railway reservation or other kind of different reservations, data used to support the launch of a space shuttle. You understand, a lot of things are going to be used in database and everybody's requirement is entirely different. Every organization's requirement is different. Database, which is the major area especially in the computer science, how to store the information and how to make it more useful in a major way. I mean, take example, suppose you are accessing a bank. What is happening, you are going a bank and you are just accessing information regarding your accounts. If your bank is able to provide the information in appropriate manner, in appropriate time, it is going to be the best use of database. That does not mean about any other information. Same way, if you go to the anywhere for a reservation, if you are going a reservation in a railways, you may get information related to the railways, different trains which are being accessible, timings, timetable, approachable places, so many things are going to be there. In the same way, if you go to the airlines, their useful techniques are going to be different. If you are working in an educational institution, the use of database is entirely different. You are accessing a very large document, a research document, research papers, different research journals or other things. Accessing requirements are going to be there. Their need and requirements are going to be different. So what the thing is that how these informations are going to be stored, in which manner, because the requirement of, as we have mentioned, every organization is going to be different. The structure of the database, the way things are going to be used, is we are going to discuss today. Now you see, model of reality. Now reality structure process, you can see it. DML, that is data manipulation language. DDL, that is data definition language, and how say it is connected with the database system, database. A database is a model of structures of reality. The use of database reflect processes of reality. A database system is a software system which support the definition and use of databases. DDL, that is data definition language, and DML, that is data manipulation language. Why use models? Models can be useful when we want to examine are managed part of the real world. The cost of using a model are often considerably lower than the cost of using or experimenting with the real world itself. Examples: airplane simulator, nuclear power plant simulator, flood warning system, model of US economy, model of a heat reservoir, maps. A message to map makers: a model is a means of communication. Users of model must have a certain amount of knowledge in common. A model emphasized selected aspects. A model is described in some language. A model can be erroneous. A message to map makers: highways are not painted red. Rivers don't have county lines running down the middle. And you can't see contours line on a mountain. It's said by the Kent. Now, very important thing, use a DBMS when this is important. Persistent storage of data. Centralize control of data. Control of redundancy. Control of consistency and integrity. Multiple user support. Sharing of data. Data documentation. Data independence. Control of access and security, backup and recovery. These are the some features where in that case you have to use the database, because when you use this a particular information to be used by many persons. Take an example, suppose this lecture is going to be going on, that these lecture contents can be utilized by the other peoples, by the other persons who are really working in that particular field. They can make the benefit of these. So these informations, if stored somewhere, can be accessed by the users. Don't use a DBMS when the initial investment in hardware, software and training is too high. The generality of a DBMS provide is not needed. The overhead for security, concurrency, control and recovery is too high. Data and applications are simple and stable. Real-time requirements can't be met by it. Multiple user access is not needed. In those cases, if you don't require that data to be shared, data to be used by other persons, or sometimes when you feel that the cost in hardware is going to be high, it is not necessary that you use it. Now, data modeling. As we have just discussed, reality, structure, processes, how the data model is going to be used in that way. A model represents a perceptions of the structure's reality. The data modeling process is to fix a perception of structures of reality and represent this perception. In data modeling processes, we select aspects and we abstract. Process modeling. You can see it here how the process modeling is taking place. The use of model reflect process of reality. Processes may be represented by programs which embedded database queries and updates. Processes may be represented by ad hoc database queries and update at runtime. You can see here the program You can use the DML, that is data manipulation language, for that reason. Now, database design. The purpose of database design is to create a database which is a model of structures of reality, supports queries and updates modeling processes of reality, runs efficiently. Abstraction. It is very important that the language used for data representation supports abstraction. We will discuss these three kinds of abstraction. One is classification, aggregation, and generalization. These things are going to be discussed. What is a classification in this case? In a classification, we form a concept in a way which allows us to decide whether or not a given phenomena is a member of extension of the concept. You can see here the customer is going to be there. We have a different customer which is linked in that, which is classified in that. Aggregation. In an aggregation, we form a concept from existing concepts. The phenomena that are members of the new concepts extension are composed of phenomena from the extensions of the existing concept. Here you can see an airplane is linked with this, wings, engine, cockpit, or any other thing. Now, another important thing is generalization. In generalization, we form a new concept by emphasizing common aspects of the existing concepts, leaving out special aspects. You can see that the customer is it may be of the first class, it may be of the business class, it may be of the economy class. In the same generalization, subclasses may overlap also. Like we have a customer, different classes are going to be there. It could be a first class and business class. Overlapping is possible in that case. Subclasses may have multiple super classes also. Like here you can see the motorized vehicle. It could be a truck also, it could be a helicopter also. The airborne vehicles, it could be helicopters also, it could be a gliders. Now, relationship between abstractions. You can see here the aggregation, the generalization, intention, this classification and extension. Here abstraction is classification, aggregation, generalization, and in concentration, exemplification, decomposition, specialization. Now, database terminology. Database models, keys and identifiers, integrity and consistency, triggers and stored procedures, null values, normalization, surrogates, things and name. Data model. A data model consists of the notation for expressing data structure, integrity constraints, and operations. You can see here the data model and data structure. All data models have notations for defining attribute type, entity types, and relationship type. Here you can see in this example a flight schedule is there. Department airport is going to be another attribute type which have been defined. Inside that there are different entity types have been given, like flight, airline, weekday, price. In the another table you can see flight and airport code. In these things there is a relationship type is also going to be there. It could be a price like that. So you can see here the different notations of that data model. Now data model constraints. Constraints express rules that cannot be expressed by data structure alone. Many things can't be defined just using by that. So static constraints apply to database state. Dynamic constraints apply to the change of database state. Example, all flight schedule entity must have precisely one department airport relationship. Now here you can see the flight schedule is going to be there, the same thing, department airport. So you can see flight, airline, weekday and all prices, this are going to be a relationship between that. Now data model operations. Operations support change and retrieval of data. Just an example, you can insert, suppose insert give flight schedule and give an example, insert this department and all. Same thing, if you select the flight weekday from the flight schedule where airline is Air India or Delta or anything like that, you can do it in those operations on based on that, and you will get all the things collected by the data. Your Delta airline schedule and Delta activities will be shown to you. Now data model operations from programs. As we have just discussed, here we can make a small program, very user-friendly programs just for doing that. For example, here we say declare C cursor for select flights weekday from flight schedule where airline is Delta. We can write a small program for that, open C, repeat, fetch into this flight, and we can do thing until done, close C. So this kind of small things can be done. Another important thing is the keys and identifier. The keys or identifiers are uniqueness constraints. A key on a flight, in a flight schedule, will force our flight to be unique in flight schedule. As we have earlier also discussed that in a table some unique keys are going to be there by which, for example, we have discussed earlier also in a educational databases. For you have taken admission in institute, sometimes examination roll number is going to be taken as a unique key, because from that point of view you can access any information about the student's activity, because that will remain as a unique key. That roll number is going to be different for each and every student. It could be that you have some more keys are going to be there which will play an important role. Consider the following keys on the department airport. You have seen flight, airport code, flight, airport code again, and different kind of things are going to be there. Here flight is working as a unique code which is there in flight schedule table also, as well as in the airport table also. Integrity and consistency. Integrity, does the model reflect reality well? Consistency is the model without internal conflicts. A flight schedule can't be null because it models the existence of an entity in the real world. So as we have just spoken, because it's very important that this can't be a null value. A flight in department airport must exist in flight schedule because it does not make sense for non-existing flight schedule entity to have a department airport. Here you can see we have defined the flight schedule and department here. Now another important thing is triggers and stored procedures. Triggers can be defined to enforce constraints on a database. For example, define trigger delete flight schedule. On delete from flight schedule where flight is equal to X. Action, delete from the department airport where flight is X. So you can see the changes will be made automatically to that particular table. Null values, which is very important. You understand why the null values are going to be useful and not useful. A database is there, you can see the customer and the name, maiden name and details are going to be there. Here null values, unknown reflects the attribute does apply, but the value is currently unknown. That's okay. None value inapplicable indicates that the attribute does not apply. That's bad. Null value inapplicable results from the direct use of catch-all forms in database design. Catch-all forms are okay in reality, but detrimental in database design. Another important thing is the normalization. We do have a different schedule. Just see the flight schedule, flight weekdays, and the flight schedule in detail, flight schedule in details. You can see these tables can be normalized. Surrogate things and names. Now here we can see that the reality, name, a customer whose name, custom, address and details are going to be there, where these things can be defined as a customer name and address, name based representation. In other way, the customer's name, address, custom in reality, here customer, custom name and address, surrogate based representation. Name based means a thing is what we know about is. Surrogate based does things and since can. Surrogates are the system generated, unique internal identifiers. Database model review. Here see ER model, which is very important, entity relationship, hierarchical model, network model, inverted models, relational model and object oriented models. Now what is this ER model is? Data structure, integrity constraints, operations. The ER model is extremely successful as a database design model. Translation algorithms to many data models. Commercial database design tools. Example, Irwin. No generally accepted query languages. No database system is based on the model. You can see that here ER model data structures, entity type, relationship type, attribute, multi-valued attributes, derived attributes, and here you can see the composite attribute and subset relationship type. ER model integrity constraints. You can see that here the cardinality 1 to n for E1 to E1 in R. Here the participation of E2 in AR, the total participation of E2 in R, and weak entity type E2 identifying relationship type are key attribute, you see that disjoint, extensions and partition. You can take that is example of ER, model example. Just see the street, here that airport name, airport code, this airport is connected, this airport address, where city, street, zip code, and again here this department name, department airport, arrival airport, flight schedule is going to be there. You can see the visa requirement, domestic flight, international flight, weekdays, and here you, in this way you can create the ER diagram, flight instead of date, time, reservations, customer name, each and everything is connected in a proper manner, that is entity. This model have been discussed how the relations are being there. ER model operations. Several navigational query languages have been proposed. A closed query language as powerful as relational languages has not been developed. None of the proposed query languages has been generally accepted. Another important model is hierarchical model. Data structures, integrity constraints, operations. Commercial system include IBM's IMS, MRI system 2000, now tooled as SAS, and CDC's Mars 4. So this hierarchical model is going to be used in that. Now here you can see that the hierarchical model data structure. We have this flight schedule which is going to be there, the part flight instance, department arrival, airport code, and customers in going to be there. You can see the here record type is flight schedule, flight instance, field type is flight, date, customer, etc. Parent-child relationship type here is 1 to n only, the flight to schedule, flight instance and customer. One record type is the root. All other record types in a child of one parent record type only. Substantial duplication of customer instances. A symmetrical model of NM relationship type. And then you can see hierarchical model, data structure, virtual records. Now see the customer name, flight stage, the flight instance and department, this customer pointer is being connected to that, your customer name. Duplication of customer instances avoided. Still asymmetrical model of NM relationship type. Now you can see here the hierarchical model of operations. You can get unique, and this search the flight, get first search flight, and all details can be done by using these kind of codes. Get unique, get next, get unique and next, by defining these properly. Another model which is very important is network model. Now here you can see what are the data structures, integrity constants and operations. Based on the Codascal DBTZ 1971's report, commercial systems include CA, IDMS and DMS 1100. Network model is data structure. Type diagram, Bachmann diagram, the same things are being changed here. See flight and this in the reservation, customer and the customer's relationship. Occurrence diagram, that spaghetti model. These models are also being used very widely. Owner record type, flight schedule, customer. Member record type here, reservations. DPTG set type is FR and CR, NM relationship cannot be modeled directly. Recursive relationship cannot be modeled directly. Now here a network model integrity constants. You can see the keys. Flight schedule is going to be there. Checks, that reservation and all these can be checked properly. Set retention options, fixed, mandatory, optional, set insertion option, automatic, manual. Network model operations. The operations in the network model are generic, navigational and procedural. Just like query, find flight schedule where flight is F2. Currency indicators are F2. Find first reservation of FR, R4. Find next reservation of FR, R5, and find owner of CR, that is C4. So things are going to be defined in such way. Network model operations, the navigation is cumbersome, tuple at a time. Many different currency indicators, multiple copy of currency indicators may be needed if the same path is traveled twice. External schemata are only sub-schemata. Inverted models. This is another different model, ADBAS. Data structures, integrity constraint and operations of this model. Relational model, data structures, integrity constraint operations. Commercial system include, maybe you are very popularly known about the Oracle, DB2, Sybase, Informis, Ingress SQL servers, that is the structured query language server. Dominates the database market on all platforms. Relational model, data structures, domains, attributes and relations. You can see here the attributes, the relation name, flight schedule, flight integer, airline we have defined in the character form, weekdays have been given in the character and price in a decimal form. So you can see the domain names, attribute names and the relations. Relational model integrities, constraint, keys, primary keys, entity integrity, referential integrity. In this you can see that flight schedule, flight is going to be there, reservations are going to be, and customers. Relational model operations, powerful set-oriented query languages. Relational algebra, procedural, describes how to compute a query. Operators like join, select, project. Relational calculus, declarative, describes the desired result. Example, SQL QB. Insert, delete and update capabilities. Relational model operations, tuple calculus, example, SQL, structured query language, select flight date from reservations to customers, where are customers and customer name is Leo. Algebra example, ISBN, you can see that the example in that way, and domain calculus example. Now object oriented models. Based on the object oriented, paradigm. Example, Simula, Smalltalk, C++, Java. Area is in the state of flux. Object-oriented model has object-oriented repository model, adds persistence and database capabilities. See ODMG 93, ODL, OQL. Object-oriented commercial system include Gemstone, Ontos, Orion 2, Statice, Versant, O2. Object relational model has a relational repository model, adds object oriented features. See SQL3. Object relational commercial system include Starburst, Postgres. Object oriented paradigm. Now in the object oriented paradigms, object class is a very important thing. Object attributes are going to be there, primitive types, values. Object interface, the methods, body, implementations. Messages, invoke, methods, give methods name and parameters, return a value. Encapsulation, which is very important feature in that way, visible and hidden attributes and methods. Object instance, object constructor and destructors. Object identifier, immutable. Complex objects, multimedia objects, extensible type system, subclasses, inheritance, multiple inheritance, operator overloading. References represent relationship, transit and persistent objects. Now you can see a small program, that object oriented model structure. You can see it, so to like syntax, that class flight schedule, type tuple, flight integers, weekdays, the parameters have been given, department, airport, method, the class international flight inherit, flight schedule, type tuple, visa required and listing through that, method, change visa requirement, visa string and boolean. The reschedule method is inherited by the international flights. When reschedule is invoked in international flight, it may also invoke change visa requirements. Same is continuing the class flight instances, type tuple, flight date, tuple, and all. You can see here that the method add passengers, new passengers customer, which have been defined boolean, adds to the passengers, invoke customer, make reservation, remove passengers, remove from the passenger, invokes customer, cancel reservation, class customer, type tuple, that the customer name, reservations are going to be there, and methods have been used here to define the things. Now object oriented model updates, you can see the class customer, type tuple, the customer we have defined here is integer customer name, tuple the frame aim string and end name string. Reservations, set flight instance, inevitable flight instance passengers, which we have defined in the main. Transactions begin, all customers, set customers makes persistent root to hold all customers. Customers, see new customer, create new customer object. See tuple customers, customer name, tuple, and this becomes persistent by attaching to a root. Object-oriented model queries. Q2 like syntax again, find the customers of all customer with the name Leo. Select tuple. See customers from C in customer where C customer name is from Leo. Find passenger list each with the flight and a list of customers name from flight out of Atlanta on October some dates are going to be there. So simply query select tuple, flight, instance of the flight, passengers, select tuple, C customer and customer name and him name from in flight instance C in passengers where a flight date is a particular date have been defined and you can see the Atlanta and all airports. So thank you all. In that way you can use the different models and how these things are being useful to that.
Definitely. Thank you, sir. Thank you so very much as you explained about the various models. But I would like to ask you, which model is considered to be the most appropriate model?
Rightly, Geetika, as we have discussed so many models, and in the beginning itself I have told you it's totally depend upon the organizational need. You can see here I have just taken only one example and I have the same example try to discuss with using different models. But still what is happening that many organizations requirement is going to be different. For example, in a particular place if you are accessing, take a database of different videos are going to be there which is going to be loaded on the website and is going to be utilized by many peoples. The storing of those videos, because the number of things are being, as you like say, people like it, that particular video are utilizing number of times. Accessibility of those kind of videos easily and things storing in big format activities are still a problem, that because in that case you have to look for which kind of model is going to be used. In organization if you are working, take again I am putting some example, if you are designing a database, CBSE is declaring a result. Now see, in the morning if you just click and enter your number and you are not getting the result within a very microsecond, you will understand. I mean, designing of database at that particular time is very important. The information which is going to be retrieved, time factor is also important. Although you know lakhs of students are there and you just want to click the information within a second. So the structural designing of those kind of things is going to be entirely different than the place you are downloading a film, movie from any kind of website. That is going to be a different kind of environment. So every organizational needs are going to be different. So somewhere, as we have just mentioned, this network model is going to be the best suitable. It could be there that the maximum places, relational databases are being used. As we have mentioned about that, Oracle and other kind of activities, they are very much in use. Just imagine the railway reservation system. You are in a queue and you are doing for a reservation. Just take a thing that if it takes more time, if it is not up to the thing real time and all, then what is the purpose of doing it? So here, which model is going to be the best suitable for storing the information of the passengers or other kind of activities, and very important thing. So it is totally dependent upon the organizational need. Simultaneously, it is also important what are the cost and other factors which are being used each year. That is also plays a very important role, because see, if you are buying a software which railway can do, many crores of rupees they are investing just to store and the organization. Many big organizations are investing a huge amount to maintain their database, like in different ways, organization. But if your organization is not that much things which can support. So there are many other different models are also going to be there. Easy things are also going to be there which can be used in that.
Definitely, as you yourself said, that depending on the need of the organization, the model is used, that is the model of the databases is used, or we can say that a particular database is used. Now the question arises, does every model, if we talk about, has its own complexity or easiness?
Exactly, as we have just discussed now, Gitika, we have told you about all those. Every models, we have just taken an example, every models have different constraints are going to be there. Every model have its good and bad things are also going to be there. There are many models where a small database is going to be handled easily. There in the other cases, suppose take a case of network model. If a huge requirement is going to be there, a different kind of data is to be shared from different places to different, so definitely no other model can play an important role. Only that network model can have that kind of facility. Although, as we have just still a lot of things need to be done just to storing the information. Lot of research is still going on that how these models can be more effective with their uses and all, having a good programming, and we have just shown you that object-oriented models, because now things are changing. Earlier, a kind of database is there, you are going to access it. Now, things are being accessed through the website. You have a large number of information stored here through the website. People are accessing is now you see that nowadays video conferencing through the databases and all with the relevant information everywhere. Latest real-time activities taking place. So now it becomes very important with all these kind of different models, and definitely each model have its own way of working. Every model has some good, some bad things are also going to be there, like security and other issues need to be addressed in these models. So some models have more security than the other model related, and still a lot of things need to be done.
Definitely. Again, when we are talking about the need of the organization, there were the times we have seen that the employees of the organization used to get the salaries by cash or by the checks, but with the trend or with the help of the technology, we have seen that now the salaries are ultimately transferred into the accounts of the employees, but the company or the organization has full information that when the person has joined till the date he has served in the organization, the company has full data. Could it be the part of the database management?
You have taken a very right example, although it is a very small kind of activity, and you have just mentioned that day by day things are more progressive. For example, you just take again it is using database. Now if you are having a reservation in the railways, if your ticket is in waiting list, if ticket is going to be confirmed, railways send an SMS to you, and immediately when the reservation is confirmed, it will tell you that. And now day by day they are just improving the things. For example, if your flight is delayed by something, the airlines send the information to you that this flight is rescheduled or what is going to be there. So this is also kind of updation kind of activities are taking. You have taken an example of salaries and all. Nowadays what is happening is that every employee is getting all the details on their emails. Not only details exactly how their salary have been calculated, what is their basic pay allowances, what is their dearness allowance, what you are going to get, how much house rent is going to be there, what are your deductions in this particular month. Not only this, in a year end you can see their fact sheet which is containing that for an income tax purpose and all, how much total annulments you are going to get in the whole year, what is the amount have been deducted towards the income tax and simultaneously they have an inbuilt kind of a structure that you can calculate yourself how these things are being calculated. No need to go to any accountant for calculation of income tax and all. Each and everything, built system is there itself. So lot of things are day by day increasing, and tomorrow maybe something new may come to you, that everything you are having SMS through the mobile, using an application you can all those. So these things are interlinked. Nowadays, as you have just mentioned, lot of mobile applications are going to be there. Using those apps, you can access lot of things. Even railway is providing that. For example, you can do the railway reservation through mobile. Now, it's very easy to say that by using an application you can do, but what is happening is that by using that application, mobile apps, you are accessing the database of the railway. So imagine how much security system and how the accessibility is being authorized, check, and you are accessing all those things is also an important part. So these things need to be addressed in a much more secure way. But it still is happening. There are many, even Government of India is making many mobile applications with using different models, which is suitable to them, and coming with all services and all to you in that way.
Definitely, sir. You have once again displayed a very good example, and another example which I would like to share with you, that while accessing my account through the net banking, I was pleased, I was amazed to see that all the data regarding my all these savings as well as the FDs and the RDs, I could look the data. I could not think of do I have a particular FD or RD in this particular bank, how many FDs or RDs I have, but I was pleased and amazed to see that there was a data for all those savings or kind of things. Thus we can say that it maintains the chronology, the system.
You see, you're absolutely, I'm going one point more ahead, Geetika. Maybe when you're accessing your account, you can see that your account is attached, the PAN number is written there. Through those, because it's automatically attached with your income tax department also. That's why sometimes you say that income tax is watching all the transactions of your bank. You can timely get connected through that. You can directly see your 26AS form also. All the income taxes related department, everything is going to be connected. So by using that particular account of the bank, you can see your all activities in the income tax department, what are the transactions have been made, what kind of tax have been deducted, each and everything. So through the bank account is it interconnected. Not only this, the important thing that even banks are also coming with the mobile banking. So mobile banking concept, even you can access through that bank not only through the net and or this small desktop and laptop. You can access the whole bank through your mobile, and that is why you can see now ads are coming. The mobile is your bank, so you can access not only this banking, many features of and services you can access through the mobile, but ultimately you are accessing through the database, and how good way the database is maintained. For example, if you are accessing some information and you are not getting in time, then it is not going to be called at the good service, and good service means here that your database is all not being accessing properly.
Definitely, sir. Though we have talked a lot about the application of this database management, but if we go towards the delimitation, could we say that if it is not manually handled well, it could increase the chances of error?
See, you are very much right, and that is why a number of time I am just putting this thing. Still a lot of things need to be done. Example I can give you exactly that, you know, that lot of fraudulent activities are taking place as ATMs machines, and automatically you are getting accessing the machine. But what is happening, the impact of thing is that people are realizing that there are fraudulent activities can take place. Still a long queues are there in front of ATMs. So imagine things are changing fast, and a lot of things need to be done in that case of security and how in a good way the database can be maintained. For example, I want some topic related to in the real-time words, exactly some real databases, and say object-oriented model, real-time object-oriented model, some research paper based on that. One way that you go and search, you are authenticating, although our search engines and all these are helping you. But how quickly they can perform you. Now that you can see, when you are going on the website, you search the informations, it becomes more lucrative. For example, you can search through the pictures also, you can search through the informations also. Sometimes you are not finding the relevant thing, you can do the advanced search also. Now these searches and these things can be done only if your database is going to be, your information is arranged in a proper database, structured way, and then it can be made more useful. So here things are going to be developed, and how much good secure can be made, all those things. security, authentication, the proper way of maintaining database is still a lot of things need to be done, and still research is going on that how these information can be more easily accessible and secure.
Definitely, as you well explained that how your privacy is very important for you on your part as well as on the part of the others. And so because we have very less time left with us, I would like you to tell all the people that how when they do not use their accounts properly, I mean when they leave their passwords without logging out. Sometimes we have seen that though we clicked we logged out, still we have clicked the option that is remembrance, and if somebody person has used that particular site, it is easily opened.
See, you are very rightly asked the question. Very important thing is what is happening, as you know very well, that when the technology is doing so much good for you, so definitely there are so many things are going to, somebody is controlling. Like what is happening, if you can do so many things automatically, somebody is watching you. Very rightly example, you have just opened your email account. Nowadays you say Wi-Fi and other activities are taking place, you are working at home, sometimes your data is being collected by some other person who is working in a neighbor area. Easily in this kind of network model and different kind of database model, somebody can hack your system, hack your passwords, hack your other kind of activity, and it is now becomes very common. Just sometimes they are doing some kind of activity only just to harass you. Sometimes they just make the changes. Now you see in the newspaper, Pakistan agency has hacked this Indian website, or say somebody had the hack of NASA site, somebody have made kind of changes, somebody hacked some the prominent person's website. So a lot of activity is going to taking place. So you have to be very careful in all these kind of cases when you are working with the passwords and with your login. That is why it is, for example, if you are using a bank account, bank always say that when after doing your activity, after log out, still you close your browser also, so that nobody can access these kind of information. But because the technology is so fast, it may access so many things which you are doing here.
Well said, sir, because we have no time left with us. As you well said, that one should delete the history after using all the important things or the important websites which depicts your personal identity. With this note, thank you so very much, and I would like to tell all the students that we would be conducting the 4th lecture on databases management tomorrow, and Dr. U.S. Pandey would be again with us.